Hello everybody, welcome back to another one of our webinars, Applied Suspension and Geometry Design. How are we doing? Javi, say hi to everyone.
Hello everybody, how are you doing?
Right, we need a bit of help here. This is going to be a super interactive session. We want to be doing suspension design back and forth with you. We just need a bit of collaboration. We need everyone to be engaged. Please also let us know if the volumes are fine between Javi and I. We're trying a bit of a new setup. So yeah, let's have a go at that. I can see a lot of people here. I can see Vanessa, I can see people from India, people from Lebanon, someone that looks to be speaking Portuguese. Everything looks fine, thanks Stasha. Where's everyone joining us from? I see someone from Mexico. Where's everyone joining us from? Let's have a quick talk here. Slovenia, Italy, someone from Murcia, what a great place. I can see Joshi from Germany.
Hometown.
I can see Kasia from Poland. I can see someone from Valladolid, Wales, India, UK, Spain, Canada. Wow, that's a lot of people. Great. Well, if everyone hears us correctly, can see us correctly, everything's good. Javi, want to do well, in case anyone doesn't know you, do a super quick introduction of yourself and who we are, and take it away, please.
Well, yep. Well, thank you everybody for coming today, for joining us in this interactive applied suspension geometry design workshop. I hope we can make the most of it in 1 hour. Of course, we need to cover the basics. We need to understand a little bit how the suspension works, what are the essential parameters, what are the distinctive sections of suspension that we'll be studying today, and then we will jump after when the foundations have been laid out to something a little bit more practical together with our web-based tools. So, as some of you might know, my name is Javier Bermejo. I'm an ex-Red Bull Racing vehicle dynamics engineer and performance engineer in Audi, in Revolut F1. And now I'm here with you guys trying to share a little bit of what I've learned during these past years. Of course, I don't know everything, and I will be very optimistic to think that this is the absolute truth, but hopefully I can give my view, and we can learn a little bit about suspension together after this 1 hour. So thank you once again for staying here with us, and sit on your your seat belts. We're going. So I want to first show you one video so you can have an idea of how what the main role of the suspension will be. So here you see probably a track replay in a passenger car, and I want you to look at how, despite the vertical movement of the body and all the oscillations, all the movements, the wheels are trying to retain position, and they are fixed, they are controlled. This becomes very, very evident in these sections. Look at all this relative movement between the body and the wheels, and the wheels, they're moving all the time. Of course, there is steering, there is roll, there is shift, but look how controlled the wheels are at all the time. And this is happening. Yes, thank you for that. Actually I can remove that. So I want you to pay attention at, as I was saying, and how this, the articulation of these links between the body and the wheels is dictating the actual movement of the wheels, as we have this vertical movement of the suspension. So this can become even a bit more evident in KNC, in a bounce test or in a heat test. So let's have a look at what's happening here.
The bounce test is perhaps the most basic kinematic test.
Hi.
In a bounce test, The vehicle chassis
Lower it just
is
in case
exercised
the-
in
yeah,
pure
a bit like
bounce motion. This is accomplished by moving the K&C rig's center table, which is attached to the vehicle chassis.
So I want you to take a look during this particular video at what is happening with the wheels, how they are moving back and forth and aft, and how the wheels lean. You can see that also very, very clearly as the wheels lose and gain camber. So this is what we're doing. Every time there is a vertical movement between the body and the tires or the wheels, these movements are happening all the time. So this is what all the suspension outboard geometry is going to need to control. And we're going to see that in a bit.
Straight up and down within defined displacement bounds. During the bounce test, lateral and longitudinal forces and aligning moments are made.
Can you see the camber on the wheel? Can you see how, as we impose this vertical motion, the wheel is changing its camber angle, its inclination angle? And can you see as well, maybe it's a bit more evident here, can you see how the rear wheel is going forward and aft? It's moving in the x-axis of the vehicle as we impose this vertical throttle. So all these movements of the wheels, they are going to be dictated by the outboard suspension of the car. We'll see that in a moment. But first, I want to separate between two different sections. The outboard side of it, which is, I think what most of us understand when we talk about suspension or suspension design, which is essentially the shape or the shape in space, like how the hardpoints, how the links of the suspensions are in space, and it is the virtual location of these points in space what is going to dictate how the suspension, how the wheel is controlled, is moving as we have this vertical movement. And then there will be one element that we will see in a bit that is going to transmit some of these forces as the car goes up and down. Of course, the links will react as well, lateral, longitudinal loads during different maneuvers. But there will be a section of there will be an element that is going to transmit the vertical forces of the tire to be act directly in something that we call the onboard suspension, which is essentially a more convenient way of sending all these forces and putting there all the elastic elements, be it anti-roll bar springs, third elements, or dampers, to control the movement of the car, the vertical movement of the car, with a bit more freedom and more authority. So again, it is the onboard pickup points definition, how we put these points in space, which affects the motion ratio, and they're going to affect how stiff this, how much we amplify this, or the other way around, the stiffness of our elastic elements. So going now into the outboard suspension components, we have control arms, upper control arms and lower control arms, usually abbreviated as UCA and LCA, and the tie rod. So they are all restricting the motion of the wheels with body movement. First, we have the control arms in pink here. They are the primary drivers of the articulation of this movement, as we were discussing, and they are also in charge of reacting a lot of the lateral longitudinal loads that the car will experience during the track. The tie rod is going to dictate as well how this articulation, or how this, how this movement of the wheel is going to happen, but it is also in charge of pushing and pulling the wheels to steer the vehicle and to give control. And then, as we were discussing, we have the push rod or pull rods. So they are essentially just rods connecting the wheels, the upright or control arms, to the elastic elements, where they are a little bit more convenient and easier to adjust, and we have more freedom to design them, essentially. Now let's have a look at the front suspension view, at the front view, and let's talk about the instant center. The instant center is found by projecting and intersecting the wishbones. It is this point in space, the point around which my suspension in the front view is assumed to be rotating. If my A-arms or wishbones, they are not planar, the true instant center is not going to be as visual as we see here. And then it will be a little bit more complicated in the case, for example, of multi-link suspension. But however, for most of our analysis, a front view should be a good first step. So this instant center is going to dictate the length of my FBSAL, which is the length of my swing arm. So how long is the arch described between my wheel and the true center of my suspension. So these two drawings that we can see, they are equivalent. So this is an analogy of what will happen if we were to replace the suspension system with one single link. So by putting these points here, this, and that, we can arrange an instant center that is convenient without having to, have this super long element. So this length is going to define the amount of camber gain that we get with wheel travel. If we get one short FBCA, we will have a lot of camber gain. So my wheel is going to lose or gain inclination a lot as there is vertical movement between the chassis and the wheels. We can see that, we can see the arch. But if we move to a longer FBCA, the arch is going to be reduced, and the rate of inclination or camber that we lose or that we gain is going to be much smaller. So this is the first consideration that we need to understand when setting our instant center. This instant center and this compensation in roll is critical for vehicle performance. As the car rolls in the corner, there's going to be a certain amount of body roll. This body roll is going to be transmitted to the body and also to the tires, which means if you have a static camber that you think it works for your car, after the car rolls, your static camber is not going to be what you think it is. So what can you do to prevent this loss of camber as the vehicle rolls? What you can do is induce pseudo camber variation through the articulation of the links, which is going to make you recover the camber that you lose because the car is rolling and the tire is rolling with some camber recovery. So if we follow this equation, I think you can you see my mouse? I think
yes,
you should, right, Alex? Right. So the amount of camber that we get in the ground is a combination of the amount of camber we get relative to the body plus the roll angle. So if we want to cancel out the camber, the roll angle, then we end up to the conclusion that if camber relative to ground needs to be 0, then our camber relative to the body needs to be exactly minus roll, or minus the amount of roll that we have on the car. So we have no variation in camber as the car rolls. However, that means that as our car, as our wheel compresses, moves up and down, there's going to be this camber recovery, which is beneficial in roll. However, when we have a pure heat scenario, when both wheels are moving up and down synchronously, this camber induced because of the geometries, the suspension geometry, is going to be detrimental. So again, how do we set up our instant center so we take the best of both worlds? If we put our instant center or make the FBSAL somewhere in the middle of the car, which is track half, our roll variation in ground relative to the ground will be minimum or 0, but it means that every time the car compresses with aerodynamics or under braking or there is pure heave motion, our wheels are going to lose or gain more camber, which is not what you want your camber, your wheels or your tires to operate. On the other hand, if instead of putting our instant center in the middle, in the center line of the car, we send it far in the infinite, then our roll variation relative to the ground is going to be maximum. Why? Because we will get no camber compensation. Why? Because the camber gain that we will get as the suspension movement goes up and down, or the body goes up and down relative to the tire, is going to be zero. And then you will not have this compensation, and you will lose directly all the camber as much as your car is rolling. So again, where do you put it? For me, it becomes clear that it should be always in the range between track halves and the infinite to promote minimum variation in either roll or heave, depending on what your targets are. Then let's talk about roll center, which is one point that it doesn't matter how we cover it today, it's going to get criticized. If we take it very simple, I'm sure experts and people from the passenger car industry, they will be criticizing me if we make it force-based, too complicated, and go deep into the maths. Then all the people that are new to these concepts, they will not probably get it right, and nobody wins at that point. So trying to make everybody happy here, roll center is the coupling point of the forces between the suspension and the chassis. So essentially, without going too much into detail, there are going to be two roll centers: the kinematic roll center and the force-based roll center. Of course, kinematic roll center is what is most usually studied in literature, and when we're getting into vehicle dynamics, our first steps, formula student, is easier for us to understand. But as we move into some more sophisticated environments, when we need to understand more what is happening in the car, we need to deal with more complex definitions, which are the force-based roll center. Why? Because at the end, the kinematic roll center is working on an amount of assumptions, but it is actually, the car is actually dynamic, so the car is cornering, forces are asymmetrical, and suspensions become asymmetrical. There is tire sliding, there is deformation, and there are so many other elements that are contributing to provoke that this kinematic assumption is no longer valid. So roughly speaking, you can understand that you can see it as here. Let's have a look at the picture on the bottom. There's going to be some side forces and some vertical component. As we said, it is the combination of these forces. It is this red component that is going to act through the swing center or the instant center, and then here around here we'll have the roll center, and this component here in red, it will create no roll, but then we will have another component in blue that it will be reacted through the elastic elements. All right, so it is the height of this roll center, how we put it, how high we set it in our car, which is going to dictate how much of the lateral load transfer, without changing the amount of lateral load transfer that we have in the car, is going to dictate how much goes to the spring, through our elastic elements, spring, roll bars, and so on, dampers, and how much is going to go through the links, and hence we will have no control of. Of course, the lower it is, we'll have more authority, we will be able to tune this, to tune our vehicle behavior more freely, but the higher it is, on the other hand, is going to make that, the transient response of the car is going to be higher, and we'll have less roll moment. So moving on, still on our front view, we'll have steering that we need to talk about. There will be two elements. There's going to be the upper ball joint and the lower ball joint. These two are going to be connected, and they are going to result in an inclination, in a steering axis. This steering axis, as we see in dashed lines, when we look at the front, is the kimping inclination angle. When we look from the side view, it is the caster angle. But now let's have a look at the front view. This steering axis is going to intersect with the ground at a distance which is going to be a scrub radius distance, the contact patch of the tire. So tractive forces, braking forces, and so on, and impacts, they are going to be considered to be applied in the center of the tire, here in the contact patch. So it is this force here and this distance here, this lever, that is going to provoke the moment of perturbation towards suspension to induce either compliance or even to create asymmetry in moments in the left and right when we have different forces, because we are going through splits. We have more friction on the left than we have on the right. So all these that we need to understand that's going to be affecting the car all the time. So if we have a high scrub radius, this can be concerning for structural reasons, and steering kickback is also related to the scrub radius. One thing that we need to understand is that the larger the kimping inclination angle, the larger our camber loss with steering, which is going to be unfavorable. It has less impact than caster, but still has an effect. And as much as we would like to have a vertical inclination angle, a vertical kimping inclination angle, it is not always possible because we are usually quite constrained in terms of packaging there. Caster angle, moving now to the side view, still talking about steering, about the front suspension, is going to change the camber angle of the wheel with steering. So more steering is going to lead to more and more camber gain. And if you think of what's happening in the sequence of the corner, you steer more and more and more and more the wheel until you hit the apex of the corner, when at that point your wheel lock is maximum and then your camber gain should be maximum. So that helps you with a bit of front bite and in mid corner. This is going to be more dominant than KPI, and we are going to illustrate that in a minute together. Usually, but not always, there is more freedom to spec the caster than the KPI, which means that, sorry, I think we moved a little bit too fast. Similarly to the front view, there's going to be, my steering axis is going to be in the side view. There's going to be a mechanical trail distance of the intersection between the ground and the FY, just as we had in the front. And it is this distance again which is going to create the moment, is going to create the moment and the heaviness on the steering, and where the perturbations are happening, such as the lateral force. So this as we were saying, this caster is making my camber angle, is creating more is helping me to have more camber gain than my KPA. So one thing that can be thought of is that caster also dials out some of the negative effects of the KPI. So we have here a very important topic as well, which is the returnability or driver feedback, which is the heaviness or what he feels when he's cornering, which is influenced by a number of factors. Factor number one is going to be the steer arm, how far this element it is to the steer axis. Again, if we think of when we're pushing or pulling a door, the farther away we are from the hinge, the less force we need to apply to overcome it. We'll have a pneumatical trail, which is going to be the force, where the force is acting, the distance between the steering axis or the hinge of our door and where the actual force we are trying to react is. So this distance is going to make this arm, is going to increase this arm and the moment we need to react. Then we will have a pneumatical trail, not to confuse with mechanical trail, which is the self-aligning moment of the tire. I was confused with, it is the pneumatical trail of the tire which is going to create this self-aligning moment in the tire. Got confused writing down there the elements. It is the self-aligning moment as again, which is going to add another element to the self-returnability of the tire before we take into consideration the suspension elements, and is going to be applied again in the contact patch of the tire. So this is going to add as well. The rack positioning, whether the rack is completely perpendicular or it is a little bit more inclined, so that's going to help as well. And the lateral force in the tire, the harder we're cornering, the more lateral force we have here, the bigger the moment we're trying to resist, and the steering ratio, obviously. Moving very quickly to the infamous antis from the side view, before we start talking about our guided exercises together. We need to understand that suspension geometry does not influence the amount of load transfer that's happening for a given longitudinal acceleration. It only changes the path. more going through the suspension links and less going through the push rod or elastic elements. So one thing that is important to note is that, as I like to see this, as I like to explain it in my courses, as the way I like to understand it, is that the percentage of anti-dive is essentially how much anti-dive force we are creating in our car because we're braking. So how much of this FX is actually helping me to stabilize the platform, and how much is actually, is pushing my car down because I have this weight transfer. So if I'm able to, if this weight transfer that we have here, if I'm able to dial this out with this anti-dive force, I will be talking about 0% anti-dive, and then my car will not be diving. All right. So if we simplify all these equations a little bit, we come up to the unfortunately we don't have the time to go through all of this in detail. We'll cover this a bit more in detail in the extended courses, but we come up with this equation, which is the amount of the percentage of front braking or the brake bias times the tangent of this angle, which is between the contact patch of the tire when we're braking, as long as our brakes are outboard, and the instant center, which is projected R and found as demonstrated in this first picture, divided by the center of gravity height divided by the wheelbase of the car. So at the end of the day, this is all a geometric effect. We're talking about the positioning of this point in space, the center of gravity height, and the ratio between the center of gravity and the wheelbase, which is an indication of how much weight transfer we're going to have. So again, the higher our instant center, the higher our anti-dive force, and the higher our anti-dive percentage. That's a way to look at it. So far, we are only talking about kinematics. We haven't discussed just compliance, which is the evil, as always repeated by many gurus. Well, maybe they are compliant, maybe they are evil, but maybe they are not. We need to understand that it's quite obvious that under load, under vertical, lateral, longitudinal load, everything is going to deform, and that's fine. It's whether we understand what it's happening, and how we can overcome that, or even use it in our favor, which makes the compliance the evil, or doesn't make it the evil. So as a rule of thumb, and what I always say in formal student competitions, is that compliance is not necessarily bad if you have a particular strategy. If you don't have any particular strategy or justified intention, then at that point, yes, you need to keep them low as much as you can. This is my rule of thumb. So everything is going to deform. At the bare minimum, I like to talk about the four, what I consider the four more dominant compliance metrics, which are steer and camber for braking, and for lateral, for cornering. So these are the very minimum that we need to understand in our car. And then we're going to talk about kinematic simulation and our RD Kinesolver, which we're going to play together in this seminar, in this workshop. So we understand a little bit of what we're trying to do. We understand suspension basics, but now we need simulation. We need a tool that helps us to define where these points need to stay in space. So we don't need to calculate everything with trigonometry every few iterations. So that's why we have kinematic solvers. And now we will run a guided exercise together. For that, we welcome you to open your tool and to keep it ready. If you have a second screen, you can play in the background and follow a little bit my commands. You can navigate to racetrackdynamics.com. Is this dash Kinesolver? If you haven't done so, I believe you have received the instructions in the previous emails. So now it's time for us to see how the parameters change with wheel motion. So the first exercise that we will be doing together is an anti-dive optimization. So imagine that you have been told that because after the some interaction between vehicle dynamics and aerodynamics, there's been some back and forth, and you've been suggested to bump up your anti-dive to 35%. So let's try to get it. Let's try to raise this anti-dive to 35% without altering all the rest of our kinematics. So we need to identify which are the points that are going to help us to achieve so. When I do that, sometimes it is clear if you imagine the points in space, if you draw them, what do you think is going to be the points and the direction that's going to have a larger effect. If you are new to this, or you are going to run more complicated or sophisticated analysis, I encourage people, as I like to do, to prepare sensitivity maps in which you evaluate and you interrogate every suspension hardpoints in X, Y, and Z variations, and you understand what is the impact on the suspension parameter based on this change, and you see the sensitivity of that. So you understand if one point is going to do a lot or is going to do nothing in your metric optimization, or if it's going to do maybe a lot, but you need to be careful because it's going to change also a lot some other parameters, and it's going to be, you will need to dial this out. So for me, in this example, I'm going to start playing with the front lower control arm, the inward point, and hopefully it doesn't affect the other parameters. So let's have a look together. There it is. So this is my baseline. Can you all see my screen? Okay, so I understand you can see my screen. What you have on our website, I believe it's a little bit different from this. So it doesn't have all the features that we have on our desktop version, but it should be enough to do some of the analysis together. So let's see. I'm going to create one right here together. All right.
Well, Javi creates this. I'm going to give a bit of context on our tools. So we're slowly transitioning into the software side of things. So we've got our Kinesolver tool on the website. That is completely free and accessible for all of you to use as much as you want. And in the meantime, we've got our Pro desktop tool that we're working on. It's still in a bit of a beta phase, but it is this one that Javi's showing off here. For now, the only one available is the online one, but they effectively do the same thing. So you will see Javi using, he's got a few more knobs and a few more things to touch, but yes, you should all be able to play with it. Is everybody on the Kine tool online? Can everyone see it? Can everyone click run and it makes some fancy graphics and animations and everything?
All right, so we're back. So this is my baseline, which has currently, if I run this, I go to results. I'm gonna have a look at my roll center, my anti-dive, which is sitting at a reasonable 30%. Okay, 30% anti-dive, which is a reasonable place to live in. But whatever, I don't want to work with aerodynamics. They are too annoying. I don't want to fight anybody. They told me 35%. I'm going to achieve 35%. So let's see how we achieve that. I'm going to move this forward, front, lower, inward point. So let's open up here my geometry. And I'm going to move this a little bit down and see what it does. So I'm going to run this and see what results I get. Okay, this has raised effectively my anti-dive to my desired value. So I am roughly at 35%, which is good. Okay, I have accomplished my mission, but I see some other things that I'm not super happy with. I need to recover some of the roll center height, and to do that, actually, excuse me, This is not upper outboard. This is, I believe, 474. 474. Bear with me.
Okay. There was a question in the chat of what is KPI. For anyone that doesn't know, that's inclination. It's a bit like caster, but turned by 90 degrees. And you should all be on the web version of this. It's a bit annoying that we can't see it ourselves. We can't see what you're doing. We can't check if you're doing things right or wrong. But again, there's 350 of you guys and girls right here. We're trying our best. So what Javi's doing here in the background is he's comparing the two different geometries, which you can see here on the top left. You can see he's got a baseline and he's got an anti-dive optimized change, which are being plotted in parallel. And what he's trying to do is he's trying to effectively get the desired anti-dive without having an adverse effect on other parameters.
Which is no longer easy, as I can see. My roll center height is a little bit screwed, so I will need to do some recovery in that. So I'm going to go and tweak a little bit this new geometry. Again, don't feel discouraged if you are not super handy with what changing this point is going to do to your geometry. This comes with understanding drawing first and a lot of experience, so don't worry. But you have the tool to play with and develop this as well. So I'm gonna go and move the upper outboard a little bit up and see how this is now. My roll center height is pretty much there now. Let's have a look. Let's run it. And okay, my anti-dive is there. I've achieved that. Nice. Yeah, spindle offset is like 0.2 of a mil, nothing concerning. Roll center height is matched, so I'm a beast. I'm very good. But okay, we have something here. We have one issue. Our scrub radius now is it has taken a hit. It has gone too high, and our mechanical trail as well. So essentially, the intersection with the steering axis, with ground in front view and inside view, so we'll need to correct that together. I will move then the outboard point to make the steering axis a little bit more aligned with what it was before. So if I click here, I'm gonna go fix the scrub radius first, which is going to be, I'm going to move this a little bit down, and I'm going to change this for the caster tiny bit as well here. I'm going to run. I'm going to see what it looks like now. Okay, camber angle is there, caster angle is there, kingpin inclination is there. Scrub radius looks like it's not there, but apologies. Opala, there it is. But it is actually quite there, so they're on the same decimal. Mechanical trail is there, rod angle, plateau, everything is there. Just my anti-dive is different. So I've successfully completed my task. My anti-dive has been optimized while retaining all the other suspension parameters.
Javi, I'm going to interrupt you there.
So let's.
There's been a couple of questions in the chat, which I'm going to answer, and I'm going to ask you something else. First of all, does the web version allow you to compare two models? The answer is no, not yet, not in the web version. For now, you can open two tabs, for example, and you can try to compare the numbers manually. You can open them side by side. Something else that I think you could do, Javi, is you could walk us through what you just did in a little bit more detail and explaining it more for someone that might have not seen much suspension before. I think that would be a good chance to explain sort of from scratch, right? I changed this, I tried to match this, I tried to make this difference.
All right. So I know I needed to increase my anti-dive. So we knew that our anti-dive is going to be dictated by where this side view instant center is in space. So my mission is now to go and raise this instance center a little bit. How can I raise it? If I lower this point down, do you agree with me that the angle of this line is going to be more tilted up, and then my instance center is going to be higher up, and then my anti-dive force is going to be higher, and my anti-dive percentage is going to be also higher. So this is what I'm trying to do. So that's been my first step, lowering this point down a little bit. And indeed, it has worked quite well. It has helped me to accomplish my desired anti-dive, but it has ruined other things, such as the roll center height. So in order to do that, then I had to compensate with the outward points. I had to compensate there to make my roll center as I wanted to. So I've played with this point as well. I've raised it a little bit. So this angle, so this element here is more inclined, and the instance center is a little bit closer to here, and then my roll center is a little bit higher. So my instance center, so these points cross much closer to the wheel center, and then the roll center height is higher. So this is what I've tried to do to accomplish to recover my roll center height. And then of course by doing all that, my steering axis was ruined. My steering axis is, let me know if you can follow me, but it is between this point and this point, these outer ball joints. You know how they connect to the wheel? This one that I'm moving and this one that I'm moving, of course, is going to ruin all my kinematics by having done that, but at least you can see. So this point here, you can see this one and this one, it is, affecting the steering axis three-dimensionally, as we can see here. It's changing the caster and it's changing the kimping inclination angle when looked from the front and when looked from the side view. So this is what I've been trying to recover, to match a little bit the inclination angle, the caster, the mechanical trail that I had and the scrub radius that I have. So these are the distances between the contact patch of the tire and the steering axis intersecting the ground. So this is what I'm trying to recover. If we now move on to give you guys some time to do an exercise yourself, and maybe you can present it to us when you're done. Let's have a look at a second guided exercise, which is KPI and caster. So here theory is quite straightforward. We've seen it, we've demonstrated before, we've covered that caster angle adds favorable camber with steering and kimping subtracts it. Okay, but how are they really coupled? This is what we need to understand. So we can do a quick study to understand it. First, let's do a memory refreshment. Again, this is my side view of the tire. This is the steering axis. So this is the angle, the axis around which my tire is going to rotate where I steer. All right. So it's going to go a little bit into the ground, as you can see. And this in pink here is the same axis, the same steering axis, but as this axis is three-dimensional, we're looking at that from the side view and from the front view. Front view, it is the kimping inclination angle. Side view, it is the caster angle. Again, both are adding or subtracting camber angle as we steer, which is desired and undesired to vehicle performance. So let's see which one is stronger, right? Let's see which one has more authority. So to make this a little bit quicker, I already have here prepared my workbook with all these simulations done, so I don't need to do all that in front of you guys. I got my baseline. Actually, can open that. There's my baseline, which is, there it is. It is my baseline, and then what happens if so what I'm doing here is a road wheel angle input, left and right. This is now with no kimping inclination angle. You can see that I'm changing my camber quite a chunk. And now this is going to be with no KPI and no caster angle. And you can see that my curve now is flat. All right. So this is no KPI and no caster. So my wheel is going to have the same camber as it moves, as it steers. If we add now 10 degree of caster angle, let's see what happens. Well, it's quite aggressive. You can see it has a very big effect. It's very powerful. So for 20 mil, I got around 3.5, 3.6 degrees of camber gain. So quite a chunk, really. But is it actually a stronger effect or a weaker effect than KPI? Well, let's have a look. This is my KPI. This is what my camber angle is gaining. Is gaining. It's always a bit messy to talk about gain and lose. Okay, I'm gonna say gain angle, which is unfavorable, while my caster angle is losing angle, which is favorable. Okay, losing angle means more negative, which is more beneficial, right? I'm trying to be pedantic here so everybody's on the same page. If we do now, we can do, so it's quite clear what is the impact of each. We can see that the authority on the caster is much larger, but now I'm going to do another round, another experiment, and see what is more or less the ratio, what is the coupling that exists between these two parameters, and see what is the order of magnitude of the effect of both. So how much caster angle should I do in order to dial out all this kimping inclination angle? All this camber angle I'm losing because of my KPI. How much caster I need to set to actually dial this out? So for me, it's something, of course, it's not perfect. It's always to be changing because it's non-linear. So my tire is moving, my wheel is moving, but to dial this out is something in the region of 2 degrees, something in that region, right? So this is just to demonstrate that my caster angles are 5 times more powerful than my KPI when it comes to camber angle gain with steering. So now let's do the third exercise together. So this is an exercise for the room, Alex, and I will need your support here to moderate a little bit the audience.
Okay, I'm ready on the
to
chat.
guide this. All right. So imagine, first assumption, we're dealing here with a high downforce car. Okay, it means it's a car with a lot of aerodynamic forces. They're going to compress. My car is going to move up and down a lot. All right. Roll stiffness at this point is almost solid. Is solid or roll stiffness, you don't care about your tire is not, whatever. Let's assume that roll stiffness is solid, and what we want to do is optimize the camber variation. So first question we should ask is, what do we need to focus on? So do we remember when we optimize our camber gain? So there were 2 different scenarios. So which one are we trying to optimize here? If my car is going to be solid in roll, so it's going to roll 0 degrees. Alex.
Yep. Question for the chat. I'll give everyone a little bit of time. There's also a little bit of delay between when we say something and when it comes through in the chat. I'm seeing a couple of answers pop in. Some people say low roll center. Other people say focus on heave, steering axis.
That I like that. I like that heave. It's going in this direction. I like this heave thing.
Reduce
Alex.
heave, roll center, instant center has to go up.
Okay, I've seen something about heave. I like that. Do we remember we have roll and heave? Do we remember that?
There's quite a few people.
Hopefully that gives a clue. What? Okay, heave, good.
But those saying
so
at the FBSA length.
All right, yeah, we got that right. FBC, yeah, that's also correct. That's part of the thing, yes. So if we want to optimize for heave using our front view swing arm length, our front view swing arm, what do you think are the most sensitive points for this? Judging from the picture, from the diagram.
Cool. What are the most sensitive points that will have this effect?
In other words, is this the tie rod location in X that is going to have an effect? It is the outer ball joint in Y that is going to have a large effect. Is it the upper control arm inboard in Z that's going to have a large effect on what I'm trying to accomplish? So what are your thoughts?
I'm hearing a bit of, see some mixed answers. I can see people say the onboard upper and lower wishbone points, people saying inboard, inner tie location, outboard points, chassis pickup, inboards in Y and Z.
All right.
Inboards in Z.
Okay, Alex. What is then the direction of this point? You know, what is the direction to which these points are going to be more sensitive? Is it X, Y, or Z? What does the class think?
Class X, Y, or Z? Let's go chat.
So you got 33% of chances.
What do we think? Bonus points for a justification. Javi, I think everyone's falling asleep.
Oh no, no way. Okay, I'm gonna bump this a little bit.
No,
all right, so
it was a joke, but because the whole chat was full of Zs.
All right. Okay, at least we got it right. We got it right. It is set. It is set, right? So any of these points, upper control arm, outer, lower control arm, outer, or the inboard points in set are going to have a large effect. So now it's a question for the class. Now you can open the KineSolver in your second desktop, your second laptop, and try to obtain a geometry that results in 0 degrees of camber variation in heave. At this point, you know, just to get the basics, a first step. Don't worry if the rest of your kinematics are completely screwed. Just try to come up with something that works. We're gonna give a couple minutes for a class to play with this. And can we take screenshots in the chat, Alex?
I don't think they can send screenshots now.
Okay. Then I'm going to write down here. I want you guys to share point that you moved. Actually, I'm going to move this. Point that you moved, new coordinate, and camber gain in bump by 20 mil. How much? What is your camber gain per 20 mil? An absolute value. Sorry, actually. So we can have that in the chat.
Okay, Javi. So, question: Are they supposed to only move 1 point, or are they allowed to do whatever they want?
Whatever they want. They're free to do whatever they want.
Okay. Okay, I think then, yes. In that case, chat. Go on the KineSolver, and based on what the default suspension is, try and play with some points to see. To see if you can achieve this effect. Okay, to see if you can optimize the camber variation. So for that, you would have to try moving points, use some logic, use some intuition, and try to see how low you can get your camber variation to be within at 20 millimeters of vertical travel, and then let us know what points you moved. You can get negative values, Martha. It can happen. No problem. Just try
it can happen. As try to make it as flat as possible. Shall we give a hint, Alex?
Give them another minute.
All right.
And chat, do let us know how you're finding it. If it's too hard, too easy. If you need more time, if you're done.
If you need a hint.
Yes. Okay, starting to get some answers. Let's give it a little bit more time to get a few more people in, and then we'll start giving hints. And for anyone who is lost, don't worry, suspension kinematics is hard stuff. And you know, this is the first time you're using this software, so don't be discouraged. The good thing, software is free and you can use it for as many times as you want. So you can always just, you know, you can have a go at it later. You can rewatch this and try and go through the exercises in a bit more slowly. Right, Javi, I think we're ready for a hint.
Or come to the full course where we explore all this in more detail.
Yep.
So I'm gonna give a hint. Is that all right, or you want me to solve?
Go give a quick hint, and then we'll just give a tiny bit.
Okay. Okay. My hint is going to go to move the upper wishbone outward in set. So this is the point I will be moving. Should give me plenty of authority to do what I want to. Excuse me. There it is. See what happens if you increase it, if you decrease it, what is the right direction, how much of a step you need to accomplish it. Play with it. At least the simulation is quick, so you don't need to submit it to the cluster or blah or wait for this to solve. It solves straight away. Thank you, Alex. I'm sure they will appreciate.
Yeah, that was a lot of work, me making that in Rust to make it go super speedy. Anyways, we got some answers in here. I think we can. I can start reading you some of them, Javi. So basically, set the upper hard points to the same height and lowest to the same height. And this guy got minus 0.06 degrees per 20 millimeters.
How much?
0.06.
How much? That's fine. That's really low. That's really low. It's very parallel. Yes, that's good.
Giving 0 degrees of camber variation in heave, but you have 100% of variation in roll. That's correct, Gonzalo. We also got upper inboard, both 18 millimeters. Camber 0.13. Got someone with 0.02. Someone with 0.1. Someone got a camber gain of 0.03.
Right. But we get it, no? I mean, I'm gonna open a new project here. It's all about run whatever. It's all about, you know, making sure that these arms are as parallel as possible. You know, making this instant center actually go to the infinite. I mean, this is far from parallel, but you get the idea. You got it right in the chat. So congratulations, that's a good job.
Yeah, really good job, everyone.
So Alex, I'll pass it to you.
Okay, amazing. Well, we've got some next few things coming up. First of all, is that we've got a set of events coming up in the next kind of couple of weeks, couple of months. First one is this Sunday. We are doing a CV building workshop, fully interactive this Sunday, the 21st of August. From our experience in Formula One, you know, we've got a big bank of CVs and people, you know, from people, friends, colleagues, and so on, people that have worked in Formula One. And combining that with ourselves, we've extracted all of the patterns that make F1 CV successful, and all the patterns that will make you have a CV that will stand out. This session is an exclusive session that you cannot book online. It's not available on the website. You can't find it anywhere. This is a session that I'm doing for a little group of people, and we've decided as a small quick offer, any purchases of our courses, either the complete guide to vehicle dynamics in F1 or the complete guide to aerodynamics in F1, will get free access if it lands before before it starts. The CV building workshop is taking place this Sunday at 3 p.m. Central European Summer Time. Any course purchases that land before then will be automatically allowed to join. If it lands afterwards, we're sorry, this is the only chance of joining, and as we said, it's going to be a reduced group. Not we can go interactive, you can share your CV, you'll get live feedback, you'll get live interaction with me, and it will be really good. If you're interested in joining, those are your options for anybody also looking to become a pro at vehicle dynamics or aerodynamics. Next, we also have on the 27th of August, we've got our free motorsport data analysis webinar. So it will be done in collaboration with data engineer from the Porsche Cup, one of our close friends. It's also completely free to join, and it will be really good for learning how to actually use data and use telemetry to extract performance and actually understand all the channels, how to make a math channel, what are like actually recommended ones, and what is a bit of bluff and what is actually useful by our performance engineer
and they will
every day.
And Alex, it is worth mentioning they will not only access the course, they will also receive the installation package that they need, the workbooks, everything, the data that they need they will receive everything, the complete pack to keep doing analysis on their own. So they will have all these benefits.
Cool. Next up, the F1 Engineer Scholarship, it's closing soon. You have 11 days left to apply. For anyone that doesn't know this yet, the F1 Engineer Scholarship is our scholarship program that allows either free or significantly reduced pricing for high potential students to our aerodynamics course. It also comes with the aerodynamics handbook, as well as many other benefits, all taught by our local expert Pedro Movilla, who was the designer of the Red Bull floor a few years ago and was working under the umbrella of the Adrian Newey team. So you've got until the end of August to apply. Anybody looking to apply, get in your applications now. The course is taking place on the 12th and 13th of September. Next up, the course itself, 12th, 13th September. You can also book it on our website directly. It contains 14 hours of super hardcore, super interesting but yet like slowly explained and taken care of, go through every step of the way by Pedro, who's probably like the most charismatic guy we've ever met. Is that true, Javi?
He is.
Such a good teacher, honestly.
And he's explaining not only theory but also all the pipelines, all the processes, all the methods, how you actually tackle Formula One aerodynamic design. It's information that obviously doesn't exist on books or university programs that are taught by professors that have been there for ages and have not had this real experience in the environment that only someone that has worked there can give you. So I think it's a really great opportunity.
Next up, complete guide to vehicle dynamics in F1, taught by the one and only Javi. If you've had a good time, if you want to learn more, or if you didn't understand a single thing of what Javi said today, and you actually want to understand the foundations and the fundamentals of everything to do with vehicle dynamics, we understand that suspension is quite a difficult topic, and it can often build on already existing knowledge, like what is a camber, what is a kingpin, what is a caster, how do the different elements interact with each other, how is a double wishbone suspension built. If any of those applies to you, you can join us on the 26th and 27th of September.
That is correct.
Online, fully interactive as well, where you can go through everything that everything that would involve vehicle dynamics. That's what Javi is here for. Finally, if you want to grab your certificate of attendance coming to this webinar, you can do it by scanning that QR code. I did some work on making it instantaneous, so no more. Oh, it's been 7 hours. I haven't received mine. This is the QR code. It works. I hope it works. It's instant. You can.
Thank you, Alex, for making instantaneous things for us. Thank you.
The amount of emails we got like an hour later. Oh, where's my certificate and so on, was insane.
It's been 2 minutes already.
Yeah, it's been 2 minutes already. Where's my certificate?
You're late. You're late. Stop sleeping.
So yes, thank you very much everyone for being here. Remember to grab your certificates. We encourage you to tag them with us, to put them on your LinkedIn, tag us, let us know what you liked, let us know what you didn't like, let us know what you found the most interesting, and everything to do with the tools. And as a reminder of the most urgent thing out there, if you want to join the CV building workshop happening this Sunday, it comes for free, and it's only for free exclusively with any course purchase, and there's no other way of accessing, and it won't be happening any other time. So finally, any more questions, feel free to chuck them in the chat now. I know someone was asking when we will give the answers for the results of the scholarships. Those will happen within, we will start answering them on a rolling basis over the next few days, and we will aim to have most answers given by very early September. In case anyone else has missed it,
please bear with us, because it's been a lot of applications and we need to review them all
There's
one
so
by
many
one
applications.
to make sure we. So bear with us. We're doing our best job to make sure we give this to the people that actually deserve it and want to
Cool, Nicholas. Send us an email with your case. We'll get back to you. Question: what textbooks do we recommend for building a kinematic simulator? I'd say drop us an email for that as well, unless you want to answer it now, Javi.
Yep. I think it's better like that.
Drop us an email.
I'm happy to cover that by email.
And we'll give you an answer for that. Besides that, anybody from Spain or surroundings, the 24 hours of F1 aerodynamics in Madrid, today was the official last day to apply and obtain early bird and student pricing. For the sake of the webinar, we'll extend it by 24 hours. And if you apply before the deadline, then we will maintain the early bird pricing. So you've got about 24 hours to put that in for now. We will get to you later, but the pricing will be maintained as long as you apply before the deadline. Deadline for the scholarship is end of August. At the end of August, we close applications and we will let everyone know their outcome. Any more questions? Is Adams useful in this case? Somebody asked.
I love this one. Yes, it is useful. If you haven't ever used it, good luck. As someone that has suffered or enjoyed, but more suffered, Adams for a number of years in the passenger car industry, I'll tell you, it's good when you try to simulate like complex stuff and you need to, experiment with load cases, with compliances, and you need like the actual, the very last, all the information, all the accuracy, and you have a very detailed simulation model. But otherwise, if you are just simply doing kinematics analysis, why bother? Why bother? Besides, I assume you don't have a license. I assume if you are going to play with that, it's not going to be very legal unless you're willing to spend like thousands of euros with that. And so do you really need that expensive software to just play with the kinematics if you don't have like a detailed compliance model of your suspension elements, bushings, or whatever that you have in your car? So probably not. But yes, Adams is useful. It's extremely useful when we're dealing with where we're chasing the.
So yes, in summary, it's really useful. Also insanely hard to use and insanely expensive, which is why we thought, let's make something that is easy and is free, and it just works. No licenses, no servers, etc. Any questions, any further questions, you can send us an email on contact@racetrackdynamics.com. You can also message us on Instagram, TikTok, etc. at Racetrack Dynamics on all of our social medias. Scholarships are completely international. You can apply from everywhere. We've had students from like literally everywhere in the world. What was the stats for last year, Javi? Like 80 countries, 60 countries.
I think around
yeah,
that.
60
Yeah.
countries we have people from, so literally everywhere. And I think that is probably most questions. Will there be any in-person sessions in Italy? We would like to, not at this time. The Madrid one is the first one we try. We're still trying out the format, moving away from also the online ones. So we will see, but we don't have any planned at the minute. How many spots are there per scholarship? It depends. There's different tiers of scholarships. So the more of a discount or the free tiers where you can access for completely free are significantly more, are more reduced than the ones where you can get in for a significant discount. Any final questions? I think we can probably call it a day here, Javi.
We can. I think it was a good one. Hopefully people enjoyed it as well.
Okay. Cool. Any questions, drop us an email. Thank you very much for being here. This is going to be the end of the stream today. Thank you very much and have a good day. Bye-bye.
Thank you very much.